Okay, so now I want to run through two quick questions for spheres, and specifically we're going to look at the equation of a sphere and the distance between 2 points on a sphere. So let's begin with the top question. The equation of a sphere with a center of -3, 2, and 5 and a radius of 4 is what? What's the equation of a sphere? So what we can do first is refer to the handbook. You can do Control F. And you should have a section here in the new FE Handbook 9, not 9.5, the new FE Handbook 10.0 on page 35. You should have this standard form equation. So this is the equation that we're trying to arrive at. And we know the center of the sphere is going to be H, K, and M. So we just need the H value, which is given, our K value, and our M value. Just plug it in here. And we need the radius. Don't forget to square it. So we take the radius squared. So based on that, we can go back. We know it's going to be the x minus, so x minus our h value, which is -3. So x minus -3. You see how we're going to get a +3 there? So don't get confused by the signs. Squared plus our y minus our k value, which is 2. So our y minus 2 squared plus our z minus our, if we go back, m value. So they use m. This is our m, which is 5 squared, equals to our radius squared. Our radius is 4, so we take 4 squared. So if you rewrite this, we have negative and negative is a positive, so it's x plus 3 squared plus y minus 2 squared plus z minus 5 squared equals to 4 squared is 16, right? 4 times 4. So based on that, b and b's out. That was an easy one to be out because it's not 4, it's 4 squared, which is 16, and we know x plus 3, y, this is y minus 2, so we need d, right? Because this is y plus 2, so this is out. This is z, this is, oh crap, this is x plus 3, so we need that, so it's going to be a. This is x plus 3, but y here is plus. This is y minus. That's right. This is x minus 3, which is incorrect. So the correct answer is A. That was easy. Use the equation. It should take you a minute, maybe 2 minutes. So now the distance between the 2 points on a sphere is what? So what's happening here is we have a sphere. And let me draw a sphere, and it's centered at this point, which is usually our H, K, and M, and this is our radius. And what's happening here is they give us 2 points on the sphere. They give us 1 point here and maybe 1 point here. And what we want to determine is the distance between these 2 points. You just use an equation in the FE handbook. So we're going to use this equation. So in 3-dimensional space, the distance between 2 points is arrived at by this equation. So if we go back, we can denote that our first point is going to be this point. So this is going to be our x1, y1, z1. This is our second point. So this is x2, y2, z2. And the total distance, again, we use this. We take the square root, x2 minus x1 squared plus y2 minus y1 squared plus z2 minus z1 squared. So the total distance equals the square root. What's x2? x2 is 4 minus x1, which is -2. Negative and a negative, double click it, squared, becomes a positive, plus our y2 is -1 minus our y1, so it's minus -1, you can double click it, square it, plus our z2 is -1, minus our z1, which is -5. Plug in -5, double click this, they become a positive, square that. Then you just solve for the distance, and if we solve for the distance by doing the math under the square root, we should get the square root of 52. So our answer is D, and we can also denote that 52, the square root of 52 can be reduced to 2 square root of 13. So just be careful there if you plug it in the calculator. So that's all. Hope that helps. And so far we've covered a lot of math for analytic geometry. So we've covered conic sections, we've covered mensuration, we've covered spheres, equations, we've covered ellipses, parabolas, and so on. So we need to talk about circles. So you just have to write all these topics down that you studied and practice for analytic geometry, and finish that and move on to the next section by checking each section. So we're still on analytic geometry. And thank you. Don't forget to subscribe and like. Take care.